Hey, we're back. We're going to do one more quick video on the kidney model with 3 parts, which is right here in front of us. So last time, if you watched last time, we did this one. And like a good TV show, we like to end on a sort of cliffhanger. And so now we're going to dramatically do this part right here. So if you remember last time, we talked about the glomerulus, this little ball of capillaries right here where you filter the blood. You make this fluid called filtrate that's going to become urine. We talked about how the filtrate moved through this whole set of tubes, from the glomerular capsule through the proximal convoluted tubule, the loop of Henle, the distal convoluted tubule. We did processes called reabsorption and secretion. We ended up making urine that ends up in this collecting duct here. I didn't mention last time this set of tubes from the glomerular capsule and the glomerulus all the way to the distal convoluted tubule is called the nephron. And that's where you do all your processes of making urine. So what we're going to do right now is we're going to zoom in on this guy and we're going to slice him open. So if we jump over here, this is a glomerular capsule right here that my fingers are touching. This set of tubes in here are the capillaries of the glomerulus. So this is the glomerulus. These are the glomerular capsules. This is the glomerular capillaries. Okay, this is where blood filtration happens. This is an afferent arteriole taking blood into the glomerular capillaries. This is an efferent arteriole taking blood out. Now what's actually cool about these two guys, and I don't know if this model shows it, but this afferent arteriole is usually bigger than the efferent arteriole, which creates pressure in the glomerulus, which pushes fluid through these capillary walls, filtering it to form filtrate. Now this is the glomerular capsule right here. This simple squamous epithelium is the parietal layer of the glomerular capsule. It helps catch the filtrate. The filtrate then flows onward into this tube here. This is the proximal convoluted tubule. I can feel the microvilli in here, which enhance the surface area to let this guy do reabsorption and secretion. Now what's cool about this view, when we cut open the glomerular capsule, we see the proximal convoluted tubule, but also if we look on the glomerular capillaries, over on this side here, we see these little cells that are kind of spider-like, and these little cells are called podocytes. They're called podocytes because they've got feet, and they look more like legs to me, but somebody thought they, on this model, someone thought they looked like feet. And these podocytes, what their feet do is their feet kind of interdigitate. Their feet kind of go like this, like my fingers are doing, creating small spaces between the feet that only small stuff, water and small stuff, can get through. And so these guys help the filtration process along. They help form the filter. Collectively, the podocytes make up the visceral layer of the glomerular capsule. So we have the parietal layer out here, but then on the capillaries themselves, and they're really on both sides, it's just they took them off over here. On the capillaries themselves, we find the visceral glomerular capsule, and it's made up of these cells called podocytes. And I think that's pretty much it for this model.